In this video, the graph of a function is given and we are going to answer some questions about it. And actually, the first of the question is, does this graph really represent a function? We have for sure a relationship between some values of x and some values of y in the real line. So given a value of x, we can find the corresponding value of y by looking at the orange curve we have drawn over here. But the question is this relation a function? And yes, it is, because we can see that there is no value of x that has two corresponding values of y. One way of looking at that is what we call the vertical line test. So I'm going to take a vertical ruler, and I'm going to move it through the function, and I'm going to see that there is no point where the vertical line is cutting the function two times. We say that the vertical line is cutting the function always only one time. So by the vertical line test, the answer is yes, this is a function. So once this question is answered, we want to find the domain and the range of this function, and we'll write it over here on the side. The domain are the possible values that the first of the variables can take, and we can see over here that the first value that has a corresponding in the function is the value -6, and the last one we have over here is the value 14. So that means that the domain is all the values between -6 and 14, and we can write this as -6 less or equal than x less or equal than 14. For the range, we need to look at what are the values that are achieved with this function. I'm going to use the ruler again, but now I want to set it horizontally. So I want to see what is the lowest value of x that I can have over here. Is in this point over here. So let's write it here, and then we'll see what that point is, at least approximately. And then if we keep moving, we'll have values that are all in the range. And the highest point we have over here is here at 9. So the values of the range go between this value over here that I'm going to say that is -4.3 up to 9. So the range goes between -4.3 and 9, and usually we use y for writing this because the values of the range are in the y-axis. So we found the domain and the range of our function. For the next question, we want to find what is the value of the function at 0. So we want to see when x takes the value 0, this is over here, what is the corresponding value of the function, and we see it over here is the value 4. So we can write as answer for C that f at 0 takes the value 4. And then we say that the point 0, 4, so the x coordinate is 4, 0, and the y coordinate is 4, is what we call the y-intercept. So it's where the function intercepts the y-axis. But what about the x-axis? We want now to find the values of x such that when we evaluate the function at x, the result is 0. So if we look at the x-axis, we want to see when the function is cutting the x-axis. And this is happening at this point that I'm marking over here, that I'm going to say is 4.5. And it's also happening over here at the point 13. So f of 4.5 is equal to 0. and f at 13 is equal to 0 as well. So we say that the points 4.50 and also 13, 0 are the x-intercepts of the function. The next question we want to answer is what is the value of the function at 2? So we want to find the value of f of 2. So we are going to find the value 2 in the x-axis, and we are going to look at what is the corresponding value of y. It's here marked with a dot, and it's over here on the axis. That's the value 3. So our answer for this question is that f at 2 is equal to 3. For the last question, we want to know for how many values of x do we have that f of x is equal to 1. So we want for the result of applying the function to take the value 1. That value 1 is over here in the axis. So I'm going to draw a line over there. It's going to be a horizontal line going through the value 1 over here. And then we want to see how many times we have values that when we apply the function, the result is 1. And I'm going to count those values. This is happening here at -6. It's also happening here at 4. And it's also happening here at some point a little bit bigger than 13, but less than 14. So the answer would be that there are 3 values such that when we apply f of them, let's call the values a, b, c. We were not asked what those values were, just how many they are. So we do f of a, or we do f of b, or we do f of c. And in all those cases, the result is 1. The last part of the question is asking for how many values of x do we have that f of x is equal to -6. So let's find -6 in our y-axis. It's over here. And let's draw a line again, going through that point and horizontal. That would be the line over there. I'm drawing here. And you can see that that line does not cut the graph of the function. So there is no value of x that when we apply the function, the result is -6. So we can write over here that f of x is different from -6 for all x. And that's the answer to our last question.